Hello Year 10 and welcome to today's lesson on acids and alkalis. I want you to write down the date and the title and the LO please. There is no starter task for today. So pause the video here and I'll continue in 5 seconds. Okay, so acids and alkalis. We can figure out whether a solution is acidic or alkaline using universal indicator. So it comes in paper form and it comes in solution form. They both do the same thing. So it can be added to the solution to determine the solution's pH, and whatever color it turns into shows you whether it's acidic or alkaline. Common lab acids. So all of the common lab acids are listed here. So we've got hydrochloric acid, sulfuric acid, and nitric acid. Can you think about what they have in common? So look at the formulae for each one. What do they all have in common? Okay, the answer is hydrogen. So they all have hydrogen in them. So hydrochloric acid, sulfuric acid, nitric acid, they've all got that hydrogen in them. Okay, and when they are dissolved in water, they will completely ionize to release a hydrogen ion, so H+. So that's what it says here. So when dissolved in water, these strong acids fully ionize. So that means their hydrogen ions come away from the rest of the elements in the compound. So here the H+ ion comes away from the chloride ion. The hydrogens come away from the sulfate ion, and the hydrogen comes away from the nitrate ion. So when they're dissolved in water, it fully ionizes, meaning that all of the hydrogens come away from the rest of the formula. So it's come away from the chloride ion, there's just hydrogen by itself. It's come away from the sulfate ion, so all this is still together, but the hydrogens are by themselves. And then the same with the nitrate ion, all of that is still together, but the hydrogen is by itself. And these H+ ions are actually what makes something acidic. So I want you to write down all of the common lab acids, and I want you to write their formulae, please, and I want you to explain what happens when they are dissolved in water. So pause the video here and I will continue in 5 seconds. So acids, when they are dissolved in water, they ionize into nonmetal ions and hydrogen ions. The presence of hydrogen, H+ ions, in a solution is what makes it acidic. So that's what I said on the previous slide. The higher the concentration of hydrogen ions, the lower the pH. pH is a scale of how acidic or alkaline a solution is. So here we have the pH scale at the bottom. So if there are more hydrogen ions, it means it's more acidic and the pH gets lower. So the pH would be from 0 to 6. Okay, acids range from pH 0 to pH 6. So the lower the pH, the stronger the acid is, which means there are more H+ ions. If we go up, all the way up to 6, that is a weak acid. So there are still hydrogen ions, but not as many. And then when we get to pH 7, that is neutral. Next, we're going to talk about bases. So bases are a group of compounds that are able to neutralize acids. So remember on the previous slide, we saw the pH scale. In the middle was the number 7, and that is neutral. and bases can counteract acids and make a solution neutral. There are two types of base. So there are bases that are soluble in water, and they are called alkalis, and they are used as solutions. And there are bases that are insoluble in water, and they are called insoluble bases, and they are used as solid powders. Now, the ones we're concentrating on today are alkalis. Okay, so an alkali is a base that is soluble in water. So I want you to get this information down, please. So an alkali is a base that is soluble in water. So for alkalis, it's actually the hydroxide anion, OH-, that makes them an alkali. So what we're going to do now is we're going to practice writing the formula for the hydroxides of these elements here. So first example, sodium is group 1 and makes a 1+ ion. Hydroxides have a 1- charge. Therefore, to make a balanced charge in a metal hydroxide, you need to have one metal ion and one hydroxide ion in Na plus OH-. If the metal was in group 2 and makes a 2+ ion, then it must bond with two hydroxide ions to achieve a balanced charge. So we're just trying to balance the charge here. So all of these will have a positive charge, but depending on what group they're in, you need to figure out what charge they'd have. If they've got a +1 charge, then it would only need one hydroxide ion to balance it out. If it's got a +2 charge, it would need two hydroxide ions to balance it out. So the first one is sodium hydroxide, and it would be NaOH. Second one is lithium hydroxide, and that would be LiOH. Third one is potassium hydroxide, that is KOH. The fourth one is calcium hydroxide, that is CaOH2. And the reason that we have it in brackets with a 2 at the end is because there's two of both of these, but not of calcium. So there's two of the entire hydroxide ion. And then the last one is magnesium hydroxide, MgOH2. So we put the OH in brackets and put a 2 after it because there's two of the OH anion. So when they are dissolved in water, alkalis ionize into metal ions and hydroxide ions. The presence of hydroxide OH- ions in a solution is what makes it alkaline. So H+ makes something acidic, OH- makes it alkaline. The higher the concentration of OH-, the higher the pH. Okay, and as we've said before, the pH is a scale of how acidic or alkaline a solution is. So here we have our our alkaline solutions. So here is 7, that is neutral. pH 8 would have a low concentration of hydroxide ions, and pH 14 would have a very, very high amount of OH- ions. So if we put universal indicator into a solution and it turned purple, then we know that it's got a lot of OH- ions and it is alkaline. If we put universal indicator into a solution and it turned red, that would mean there are a lot of H+ ions and it is very acidic. If it turned yellow, that means there are H+ ions present, but not a lot of them. It's a weak acid. If it turned blue, it's a weak alkali. And if it turns green, it means it is neutral. So when an alkali reacts with an acid, it neutralizes it. This brings the pH to 7, which we could confirm with a universal indicator as it would turn green. So 7 is in the center of the pH scale. If you have an acid and an alkali, they will cancel each other out and you will end up with a neutral solution. So when an acid and alkali react, the following word equation applies. An acid plus an alkali goes to a salt plus water. And underneath we've got an example. Hydrochloric acid plus sodium hydroxide goes to sodium chloride plus water. Here is the simple equation. HCl plus NaOH goes to NaCl plus H2O. Now you can see on this side of the equation, so the reactants, we know that hydrogen ions fully ionize from the the hydrochloric acid, and we know that the hydroxide ions fully ionize away from the sodium. Now we've got one H here, one oxygen, and another hydrogen. We've got two hydrogens and an oxygen. Now if you look over here, we've got two hydrogens and an oxygen. Those ions come together to make water, and then you are just left with sodium and chlorine, which come together to make sodium chloride. So I want you to make notes on this page, please. I will continue in 5 seconds. Right, so we have an example here of sodium hydroxide and hydrochloric acid. So the hydrogen comes away from the chloride and that is acidic. Hydroxide comes away from the sodium, that is alkaline, and they both come together to make water, which is neutral. Okay, so this means the solution now has a low concentration of both H plus and OH, so the pH falls right in the middle. And the reason that there is a low concentration of H plus and OH minus is because they have come together to form water. We show the neutralization ionic equation as H plus OH minus goes to H2O. Okay, so it's just about hydrogen and hydroxide ions coming together to make water. And then what we have left is a soluble salt. We've got sodium and chlorine. They come together and make sodium chloride. Okay, so that is it for today's lesson. I hope you all have a wonderful day.